Hi guys, today we're going to talk about medians, altitudes, and perpendicular bisectors. So what I'm going to do is have you take out your notebook and take notes. You'll also be copying down some theorems for your homework. So this is on page 137. The first thing is a median of a triangle. You need to know the difference between all three of these words that you're going to learn. The median of a triangle is a segment from the vertex to the midpoint on the opposite side. So in this triangle, from this vertex, if you find the midpoint, and we know the midpoint means these two pieces are equal, that's the median right there. It goes from the vertex to the middle of the opposite side. So I'm going to draw a couple more, and then I'm going to draw in the medians for you. Let's say we had a triangle that looked something like this, and I wanted to draw the median from this point. Well, I would find the midpoint, so midpoint is halfway through, and then I would draw a line like that, and that means those two are equal. If I wanted to find the median from this point, I'd have to find the midpoint, maybe that's about halfway, and draw that line. And if I was going from this vertex, about halfway would be like that. Whoops. So that means these two parts are equal, and these two parts are equal. So that's the median. The median is always inside the triangle. The altitude of a triangle is a segment from a vertex to a line that contains the opposite side. And it's the perpendicular segment. I forgot to say that. It's the perpendicular segment. So let me show you what that means. If I was going from this vertex and I wanted to draw a perpendicular line, we know that perpendicular lines always form right angles. So a line to form a right angle with this opposite side would be right here. So that would be the altitude of this triangle from this vertex. If I wanted to draw an altitude from this vertex to this triangle, this side over here, okay, I would have to draw a line that's going to make a 90-degree angle. One way you could do it is have a ruler in here. Of course I can't get it. One way you could do it is take your ruler and line it up on the side. Oh, this is too long of a line. On the side that you want to draw the perpendicular bisect or the altitude to, and kind of follow it along and see when does it hit. Well, it hits outside the triangle. So for this altitude, you have to actually draw it outside the triangle because that's where it becomes 90 degrees. So it's altitudes are a little higher than medians because medians always go to the midpoint. On this triangle, if I wanted to do the altitude from here, I'm going to erase this one. So here's my opposite line. I'm going to extend that line out, and then if I figured out where I could make a 90-degree angle, it would actually be, again, outside the triangle. So that would be my altitude of this triangle. If I was drawing the altitude of this triangle, it actually would end up being the same line as the median because that looks about 90 degrees right there. The last definition is perpendicular bisector of a segment. It's a line that is perpendicular to the segment at its midpoint. So you have any segment, find its midpoint, draw a line that's perpendicular. That's a perpendicular bisector. It can be a ray also. A ray could be a perpendicular bisector to a segment. If I had a segment that wasn't, straight like this, to find the perpendicular bisector, find the midpoint, and that would be the perpendicular bisector. Therefore, these two parts would be equal. What I'm going to have you do today is on page 137, I want you to put those three definitions in. Then you're going to put in theorems 3.5, 3.6, 3.7, and 3.8. Okay, so you're going to put all those theorems into your notebook. On page 139, at the top, it says the distance from a point to a line. I actually want you to copy that definition of distance into your notebook as well. And we will go over. I'm not going to have you do any problems. We'll just do them together tomorrow. So that's all you have to do. See you tomorrow.